Hello and welcome to this series of videos about measurement technology, measuring what is it, what will be, or how is it defined, how is it working, and so on. When it comes to measurement or measuring technology, I think most of us do think about something like this here, measuring length, either with this simple triangle here, or maybe this is more like a child's play thing, maybe something like this, measuring. Or maybe some of you think of things like that, so this is multimeter, so measurement, What is measurement? Measurement is a good thing to take care about illusions. The humans are not really able to really quantify things. So here, for instance, that's a visit at IKEA. Not to make any advertisement, but here we bought new furniture. Here I was very confident that my car is big enough, and I piled on and piled on and piled on, and suddenly my wife asks if we could manage to bring this home. Of course, I mean, there's a big car. Well, I should have measured. Typical misjudgment, because humans tend to see it in scale. If you're in a big room, a big thing looks small. If you're in a small room, the same thing looks huge, simply. So humans are not able to quantify things. So measurement is the best method of getting rid of this. Of not to fall into illusions. The best method against illusions is measuring, weighting, counting, things like this. Quantify things. And exactly this is what measuring technique is about. We want to have a number which is not relying on our feeling. We want to have it fixed. Let's see what is necessary. So most measuring systems, how are they built up? So we'll make a small drawing here. I will write measurement system. In each measurement system, we do have something which is called a sensor. Okay, so this is a Sensor. Messwert aufnehmen in German. The sensor. What does the sensor do? The physical quantity, so the thing I want to measure, is having influence on this sensor. Okay, so that's here the physical part. Physical quantity that's influencing the sensor somehow, and the sensor it changes some property. Okay, this either be a mechanical property, or very common are electrical properties. Yeah, so it's changing something. Sensors, there might be active sensors. Okay, active sensor gives energy, is not relying on power supply. The physical quantity is influencing the sensor, and an active sensor gives energy away. Yeah? And there is also a passive sensor, and this is just changing, but without giving energy away. Yeah? So maybe it's changing, like for instance the shape if it's a mechanical thing, or the resistance if it's an electrical property. That's it. Yeah? So there are active sensors, passive sensors. However, what all sensors are in common, that it changes some property, yeah, under the influence of a physical quantity. Okay. These sensors usually are very, very small. These changes of the sensors are very small. Yeah? So we cannot watch it, yeah, or very, very rarely, or very hard. It's very hard to watch because the changes are so small. So we need something which make these changes stronger, bigger. Yeah. So we need something in here in our measurement system, yeah, which is amplifying, and that's an amplifier. The amplifier takes the signal from the sensor and is gaining the signal. Okay, it's making it bigger simply, so that we can watch it easily. Yeah? So that there is enough power to move a pointer or something like this. Yeah, this amplifier, this changes in the sensor are very small, and after the amplifier it's big. Yeah, usually the amplifier, if the sensor is also requiring power supply, so if it's a passive sensor for instance, so if there is also a power supply, then the amplifier usually provides this power supply. Yeah, so that's the signal here, and it's the supply, power supply, if necessary. Okay, and the amplifier is simply gain the signal, make the signal stronger, yeah, to make it possible to observe. Okay. That's the thing of an amplifier. This part here, this part, with the amplifier and the sensor is called Messwertaufnahme. Yeah, measurement recording. Yeah, it's the recording part. Yeah. Recording, observing, measuring. That's the recording part. However, just because we have now a signal which is big enough to watch, we need something to watch. Yeah, so we need here something, a third thing in the chain. Yeah, so there is, for instance, display. Okay, there might be analog displays with a pointer, there might be some digital displays with some 7-segment elements and so on. Display, one possibility. Yeah? Then there might also be the possibility of computers, yeah? Databases and so on. Data recording. Yeah? There might be hard drives, there might be databases, there might be tapes, whatever. Yeah? With the signal now strong enough, we can go to displays, we can go to data recording devices and so on. This thing here, this right part is called data processing. Okay, measurement processing. Here we have measurement, here we have the processing, recording, processing. Sometimes this amplifier does also a little bit of processing. What does it do? Sometimes filter. It will sometimes filter. What does it mean, filter? Filter means unwanted pikes or something, wrong measurements need to be filtered out of the correct signal. Yeah? This is sometimes done directly in the amplifier, because we know the sensor has this and this, this and that property, and there is some noise on it, then we may filter it in the amplifier. This filter here, and also this part. So I will take a part of the amplifier and the display data recording and so on. This is called the processing. Data processing. Okay. Messwertaufnahme, Messwertverarbeitung. And the only part which is in the processing is this filtering of the amplifier. That's the typical structure of a measurement system. Yeah? Not all of our measurement systems are looking like this. Yeah? However, most of them do. Yeah? This is called a measurement chain because it is a chain structure. One example of what we've just seen, one mechanical example, so that it is very easy for you to understand. I draw now something and explain what it is. Yeah? So, in some measurements, we do have a thing which looks a little bit like this. It's a tube. It's a tube shaped like a G or something like this. Yeah? The thing is, if we now blow in here some air, pressure, here's pressure. Pressure from any system, yeah. That's our physical quantity, this pressure. This is what we want to measure. And this pressure now applies force to the walls of this tube. Okay, so there is always a little bit force here, and of course here also. Yeah? And because the area of this tube on the outside is bigger, yeah? So there is more square meters, if there's even meters, there is more square, there is more area simply on the outside than on the inside. So the total force on the outside is bigger than on the inside, and this little tube tries to stretch. This little tube is our sensor. Okay, this is the sensor which tries the property which is changed is the form. Yeah, it's a mechanical property because of the physical quantity applied to the sensor. The sensor is changing its shape. It's changing one property. These changes are usually very small. Yeah? I'm pretty sure you heard about things like hook and elasticity, deforming things, and there is one part where the deforming is can be removed again. Yeah, so it's elastic, the elastic thing, and then the deformation is permanent. Of course, we do not want to make this deformation permanent. We want to have it like a spring. So when we do not apply the pressure, it should go back to the usual form, to the original form. Yeah, it's a little bit working like this carnival, you know, this air whistles there, which are getting long. It's pretty much the same principle. Okay, so because we are in the elastic area, these changes here are very small. Yeah, so we need something. We need something to make them stronger or bigger. Yeah, then there is some gears are in there usually. Yeah? Small one driving a big one, and then again a small one. Yeah? This gearbox which is inside here is nothing more than a mechanical amplifier. Yeah, it's just amplifies, it's gaining this little movement here up and down into quite some turning of the middle gear. Okay, and what follows next is a pointer. We do have a pointer connected to this middle gear. That's our display. Okay, that's our display, and in totally we do have now a bin. Yeah, doesn't really look nice. A manometer, mechanical manometer, pressure measurement device. We have a sensor, we have an amplifier, we have a pointing device, a display, and here we have a scale, how much quantity of pressure we do have. And the more we are moving here, the more pressure we will get displayed. Yeah? Issue here is usually the pressure is not constant but has some ripples on it, so the pointer tend to shake a little bit around the position. Yeah? Then you see a little air bladder up here, yeah? And the rest is filled with some liquid, and this liquid is purely in there to add more friction, yeah? And to prevent this shaking part of the pointer. Okay, so because of this liquid in there, the pointer will stay, and this noise, yeah, this is filtered by the liquid, by the friction. We will later talk about static behavior and dynamic behavior. The static behavior is if the pressure is constant, then this thing is good. That is damped a little bit, yeah, filtered a little bit. If the pressure is changing and I want to see every pressure change, then this damping is not that good. Yeah, dynamic behavior is getting worse with this liquid filled things. And maybe some of you have already seen if there is no pressure applied, yeah, then there's already some display. what happened there is that this spring here, this little tube, was not moved in elastic area. It is already too much pressure was applied, and there was already permanent deformation. Yeah? So this thing you can throw away afterwards. Yeah? So this is typical example of what we talked about, this measurement chain, in one device. Yeah? Sensor, amplifier, display, one device. These signals here, these ones, they're usually norm signals. Yeah. So one signal which is there are several signals defined. Yeah, for instance 0.10 volt. Yeah, 0 means 0, 10 volt means maximum. This is one possible signal. Voltage signal. There are also current signals, for instance 4 to 20 milliamps. Yeah? 4 milliamps means 0, 20 milliamps mean maximum. Yeah? Why is this 4? This is a so-called live zero. Why we use this, we will see in an upcoming video of this series. Okay. So there are a number of norm signals defined. These ones are very usual: 0 to 10 volt and 4 to 20 milliamperes. Unipolar signal. Then there is a bipolar signals, -10 to 10 volt and -20 to 20 milliamperes. This is also a very common signal. Which of them to choose and what are the advantages and disadvantages we will cover in the upcoming series of this video, in the upcoming videos. Yeah, that's it. So these measurements, these are now quantified things of the physical part. So that's not just a feeling, that's how it is. And these signals may be displayed, recorded, or maybe even used in control systems and so on to influence the physical quantity somehow. That's then up to the usage. That's then up to the processing. But this measurement itself, the recording, is always the same. Okay. It might be to ensure some product quality or whatever. I said physical quantity. Okay. The physical quantity is always some number, and of course there's not only the number, there is also the so-called unit. And what this is about with the units and so on, we will cover in the next video. Okay? For this video, it's just the structure of the measurement system. So, thank you for your attention. See you next time. Goodbye.